So again, I'm recording for those who can't come in today, no? Okay, so yung lesson natin ngayon is I think ay RSM ba tayo? No. Linear regression pala tayo, no? So itong last two lessons natin is fairly difficult, no? Medyo mas mahirap siya than normal than the previously discussed. Pero kaya naman siyang i-grasp as long as you get the gist of how it works, then kaya niyo mag-solve ng problems and apply it to your studies as well, no? In fact, yung most studies, yung mga ginagawa dito sa Triple M14, no, yung mga final project natin dito sa Triple ME14, most projects parang in some way or manner gumagamit sila ng linear regression, no? So I really think na if you grasp the concept of linear regression, pwede nyo siyang i-apply sa current na studies nyo ngayon, yung pang final project nyo. And I'm looking at I've reviewed some of your work, no, doon sa yung mga na-propose nyo, and most of them can really take advantage of linear regression models, no? Okay, so let me just open this. So this is linear regression, and I think in some way nagamit nyo na tong linear regression, no? Kasi when we do experiments, kunwari pag nag-experiments tayo sa class, tapos usually when we do experiments, no, meron tayong mga trends na nakikita, and most of the time what you do in Excel, no, ang ginagawa nyo is pina-plot nyo siya tapos naglalagay kayo ng trend line. So in that sense, actually yung ginagawa nyo is some part of linear regression, no. So kumbaga nagmo-model kayo ng or nagfi-fit kayo ng line doon sa data na nakuha nyo. Okay? So in essence, no, in most of the time pagka nag-linear regression model tayo, it assumes na that one factor is related to another factor. So we call the independent factor. So in this case, if this is if you look at this slide, no, we have a global average temperature versus number of pyrates na slide. And if you look at it, parang meron siyang trend. And in this case, yung X variable dito, we call them as the regressor, no? So meaning sila yung sila yung independent variable that you can manipulate, and yung mga na-affect na variable is called the regressant. Okay? So wait lang. Parang baliktad ata. Wait lang kalasa. Let me double check. The regressant. I think that's correct. Wait lang, let me check my other notes. Okay. So tama naman. So again, the regressor is the independent variable, and the regressant is the dependent variable. Okay. So this is pagka we only have one variable and we have one response variable, then ang tawag natin dito is just a simple linear regression, no? And this is what most of us are quite accustomed to, no? But in this lesson, we'll also be looking at multiple linear regression, no? And in multiple linear regression, we can have many regressors, I mean, and but we only have one regressor, no? So one regressant, I mean, which is our response variable. Okay. So if you have a simple linear regression, then you will end up with a model. We call this as a model, no? And the model is basically a formula. So this is a model is used to, given a certain amount of data, ang main purpose naman ng isang model is to become a predictive tool, no? So for example, if you have historical data, sobrang dami mong data na collect, tapos you develop your model, and from that model you end up with an equation, then you can use it to predict kung ano yung magiging response ng isang system given a certain variable ng ano natin doon sa regressors natin. Okay? So this is extremely useful, no? Say for example, you have sa isang process mo tapos you are dealing with kunwari time and temperature, no, and the time you soak your material in a certain process, nakaka-affect siya sa parang property na or temperature, nakaka-affect sa properties, no, and when you plotted it, yung mga through years of experimentation, no, historical data, you found out na meron pala silang model, no. Then you can readily predict kung ano yung magiging parang resulting properties ng isang material mo simply by just inputting it in the model, no. Okay, so simple linear regression again is ano no very useful, but it assumes na meron kang linear relationship, no. So sometimes this works, no, kasi in kahit yung mga relationships that are not linear, no, kunwari mga power relationships, if you zoom in close enough, for example kung mag-zoom in ka, no, so let's just say na ano wait lang and tablet. Okay. Okay. So let's say na meron tayong parang curve, no, relationship, kumari ang response versus ano is curve. You might say na hindi na mag-work tong linear relation model, no. Pero if you look at a local na ano dito, local area, and dito sa local area na to, you zoom in, you will see na meron silang local na linear relationship, no? And that can be still useful, no? So kahit na, kunwari, ito yung region of interest mo lang. Kunwari, yung operation settings nyo is just in between these settings. Let's just say na, temperature of, from temperature of 600 to 625 degrees Celsius. Yan lang naman yung, kunwari, pinaglalaroan ng process nyo. Tapos, you find out that it has a linear relationship, then the predictive model can still apply, no? Even if the overall na parang relationship between the yung kunwari yung temperature and the resulting process is overall non-linear, pwede pa rin magkaroon ng parang local linear relationships, no. So simple linear regression is helpful in that regard, no. Okay, so I think that's enough, no, para maka ma-build yung parang understanding nyo of linear regression model. If you want to get really into it, no, I suggest na you read the modules. I think this is the old file pala. Maybe I'll be updating this, pero essentially ito yung ano natin, no? Yun yung gist ng linear regression model. So you want to find a linear relationship, or you want to first, kumbaga, i-establish mo muna kung linear nga ba yung relationship, and if it's linear, you can now do the prediction. Okay, so let's do a simple calculation. And actually si linear regression model, it's medyo mahirap yung multiple linear regression models, pero yung simple actually madali siya kasi si Excel has yung data analysis toolpack natin. Kaya niyang yung one click, no, so hindi natin kailangan mag yung manual method, pero I can still show you how the manual methods work, no. So one important concept of the linear regression model is what we call as your yung coefficient of determination, which is yung R-squared. And we always look at this parang sobrang common ng R-squared na term na to, no? So R-squared is it's a value between 0 and 1. So the closer it is to 1, the more the more linear the relationship based on the data. So we can say that um, if your relationship is or if your value of R-squared is equal to 1, then it is perfectly linear, no? Meaning that the observed y variation can be totally explained by the simple linear regression model. So it's just saying na parang how much of the model can be attributed to the data that has been collected. So if it's very low, ibig sabihin yung data does not um, the data does not confer with the model that you have produced. No? So meaning it could be na hindi talaga linear yung relationship. Okay? Now, we won't get into residuals na dito, no? Hindi na siya masyadong importante for our discussion. So, what we'll do is, and we can also compute actually yung confidence interval, pero hindi na natin gagawin for this course, no? But this can still be important, pero right now, hindi na natin siya itatakol, no? What we'll be doing is first and foremost, identify natin if a certain parang process has a linear regression model, and if so, ano yung predictive model to quantify or to parang identify that linear regression model. No? Okay? So, we could do siguro anong gagawin natin? We can do one example, no? Try muna natin. Sige, mga multiple linear regression model na to. So let's do simple linear regression model na muna. Oh, wala siyang simple na example. Wait lang ah. Let me open yung other file. Saglit lang class ah. 114. Mukhang eto na din pala yun. Sige. Okay. Siguro ang gagawin na lang muna natin is kahit test lang natin yung data, one variable at a time lang muna. Okay? So, para lang makita natin. So, saan ba yun? Where is our data? Ito. Maybe we can get a konti lang kasi example na binigay dito. No? It's only one example. So, let's do ano lang muna. Hanap tayo ng linear as simple. So, let's get random data. No? Saan yung data natin? Pwedeng siguro ito. Wag to. Or we can get from the internet. Anong gusto nyo? Height versus free throw percentage. Data set. Baka may manap tayo. Ay, pangit yung data. Sige, ito na lang gagamitin natin. So gawin natin is let's analyze this one model, one variable at a time. Tapos next ituturo ko sa naman sa inyo yung multiple linear regression model, no, wherein we do it multiple variables at in one particular time, no. So kunin natin to, and hopefully this is a kaso picture kaya to, or is this a data set? Kasi kung picture siya, let me save it, no. Documents. Tapos, Excel. If it's Excel, pwede natin siyang ano, no? Yung tulad ng ginawa natin dati. Oh, bakit nawala? Hmm. Nakikita ba yung Excel file? Parang hindi, no? Ulitin ko. Ay, nakita na pala. Let me open again. Yan. Kita na dapat, no? Nawawala. Excel. Yan. Okay, so this is our Excel file, no? And let's try kung may mapupull tayong data. File, we go to data, tapos get data, and we do get data from file, tapos from PDF. And let's open the PDF file. Ay, hindi nyo pala nakikita, no? Ulitin ko. Ito. Okay, ulitin ko. So we go to dito sa top part, punta tayo sa tab ng data dito sa ribbon na to. Tapos we press get data from file and from PDF. Actually, class, you can also use this ano, no, from web. So for example, kung nasa isang website, and I think some of your projects na kinukuha nyo ata sa internet yung data nyo, no? So to make it easier to transfer the data from the website to Excel, pwede nyo actually gamitin ditong from web na ano, no, na feature na to. So it works the same way dito sa yung pagkakukunin natin from data. But it only works if the table is formatted or kung yung HTML niya mismo, yung mismong code niya is formatted as a table na ano, no, na block. Kung hindi siya naka-table, kung picture siya, hindi niyo magagamit itong get data, no. Pero tingnan natin kasi hindi ako sure din kung I feel like naka-picture din ata to. Pero let's see, no. Kung naka-picture to, hindi natin magagamit tong ano na to. So let's go page. Anong page kaya yun? Check natin. It's in page. Saan yung page? This is page 19. Meron mga page 19 dito. Ay, wala. Okay, it's an image so hindi natin magagamit. So, what I'll do is i-manually copy ko na lang. No? So, let's do. So, we have y. And let's just assume class again. Normally, if we are given this kind of ano, no, dapat multiple linear regression model. No? Pero for the purpose of showing you how to do simple linear regression wherein kumbaga one variable lang tayo, try natin na one variable at a time. So we'll develop a model for x1 and y. Then we'll also develop a model for x2 and y. Okay? So again, y is designated as our response variable or our regressant. Tapos itong two regressors natin or the independent variables are the factors that we are looking at. So itong x1 and x2. Okay? So we do 745. 895 442 401598. Tapos we do 36, 37, 47, 32 and 1, 66, 68, 64, 53, tsaka 101. Right? So ito na yung data natin. No? So to do the simple method, ang gagawin natin is we go to data, tapos punta tayo sa data analysis. Tapos dito sa data analysis, we have itong parang regression na na option. So if we click regression option, we can choose the Y range and we can choose the X range. Okay? So I'll choose the Y range, no, and sabihin ko na isama ko yung labels. So if I'm including the labels, iti-tick ko tong labels na to, no. Tapos actually pwede siguro ang gawin natin is i-label natin para mas maganda, no. So price, age, and area. So answer muna natin, no. So that's a good thing about labels is pagka ginawa niyo yung simple ay yung yung data analysis toolpack, ang mangyayari is pagka ni-release niya yung parang ANOVA results, ang makikita niyo is yung yung exact name ng variable na yun and hindi siya naka-y lang or x1 or x2. So kunwari ganyan, input natin yung y range which is this one. Then you can input the x range, no, which is this one. Okay? Tapos let's do labels. Tapos confidence level natin, if hindi niyo siya pinili, ang default niya is 95. Pero if you check it, then you can specify kung ano yung confidence level. No? So wala namang sinabi sa problem. So let's just do 95% confidence level. Now we have this additional option. No? Itong constant is 0. So constant is 0 means that you are parang yung sa y equals mx plus b part, pipilitin mo na sa b is equal to 0. Okay? So, there are cases where this makes sense, no? Like, ano bang case na pwede siya mag-make sense? Yung tipong relationship na if 0 yung regression mo, dapat 0 din yung regressor. Parang gano'n, no? So, let's just say, kunwari, sige. Sabihin ko muna yung opposite. If you do something like, kunwari, taxi fare. Pag taxi fare kasi, yung amount traveled mo is equal to or is linearly related to the amount of yung fare mo, I mean, is proportional to the amount the distance traveled, tama? Pero if you travel 0 distance, meron pa kayong babayaran na parang anong tawag nila doon? Yung flag down fee ba tawag doon? Basta yung parang hindi ko alam kung 40 pesos ata. Basta yung initial na babayaran mo pag upo mo pa lang. So yun yung plus B na term na yun, yung constant. Now there are cases wherein merong mga relationships na zero siya. No? Let's say for example, time and distance. No? Kunwari, the amount of time na nagta-travel kayo versus a distance na tinravel nyo. So if your amount of time that you traveled is 0, it is expected na amount of distance na na-travel nyo is actually 0 as well, no? So in that sense, kung ganun yung scenario nyo, wherein you know that when you have a 0 x variable, it translates to a 0 y variable, then you need to check this constant is equal to 0 para mas accurate yung model nyo. But if you don't know the relationship, if hindi nyo talaga alam kung ano bang behavior na, then you can leave this unchecked. No? So dito, parang hindi naman natin kailangan i-check yung constant is 0, no? Kasi kunwari, yung age ng, I think this age of the, I don't know, of the cottage itself. If age niya is 0, hindi naman necessary na ang price is equal to 0. Tama? So, wala namang relationship yun. Tapos kung ang area din niya or sige, one variable at a time tayo. Kung age niya is 0, hindi necessary na the price is also 0. So, doesn't make sense na i-check natin si constant is 0. So, let's leave that behind. No? Leave that unchecked. I mean. Okay? Tapos, we can select an output range and let's just place the output range dito. Tapos, we'll do residuals. Etong residuals, again, hindi natin kailangan itong malaman ngayon. Pero if you want additional information, no, you can actually select all of this. So, pwede siguro ang iiwan lang natin is line fit plots lang muna. Okay? Tapos, I think pwede. Sige, isama na natin residuals. Residuals, by the way, class, it just means that kung ano yung, it's the difference between yung prediction ng model nyo versus yung actual na observe. Okay, so this means that kung mas maliit yung residuals, no, mas maganda yung results kasi kumbaga mas ano mas close yung relation, close yung observed data versus the expected data. Okay? So let's try to do this, no. Put natin siya. Then we get a summary, no. So meron tayong ganito. So, itong predicted na to, this is yung predicted ng model natin. So, ito, kumbaga, yung linear na model natin. Tapos, itong price, this is yung, ano niya, yung observed, kung ano yung actual data na pinapakita natin. So, we'll see, ito, meron tayong mga statistics na nakita dito, no? So, we have our R-squared value. Meron tayong multiple R. Tapos, meron din tayong adjusted R-squared. So, ang importante sa atin dito is actually itong ano, no? Importante sa atin is this R-squared value. So, itong R-squared value, ito yung coefficient of determination. The closer it is to 1, then the more likely na, the more nag-fit yung observed data doon sa expected data natin. Okay? So, kumbaga mababa yung residuals niya. Alright? So, dito sa ano, itong adjusted R-square. Adjusted R-square is important when we are, dito hindi siya importante, no, kasi simple linear regression lang naman to. Pero adjusted R-square is important when we do multiple linear regression, no. So mas may explain ko to later, pero just a preview, no. When we say adjusted R-squared, it's important because let's just say na itong we have this age, no. Itong price versus age. If we add another variable, let's say itong area, the tendency of the R-squared value will always go up, no? Never siyang bababa. Okay? So, tapos kung kunwari, magdagdag pa tayo dito, like for example, location. Let's just say location. No? Hindi ko alam kung paano mag-work yun. Pero location. Tapos kung nag-affect pa yun sa price ng cottage. If we add the location, kahit hindi niya ini-improve yung model, because you added a new variable, always yung R-squared mo tataas, which will give you a sort of false sense of ano, no, parang fitting ng data. We call this as overfitting ng data, no. So ang nangyayari is hindi mo talaga alam if the new variable that you've added improves the R-squared, improves the model, or nag-improve lang siya dahil yun talaga ang nature ng R-squared value. Because if you look at the R-squared na formula, no? Let's look at R-squared. How is R-squared computed? Ito siya. R-squared is 1 over SSE minus SST. Di ba, if naalala niyo yung SSE, which is the sum of squares of the error, no? If you remember, kunwari, kahit yung first lesson natin sa ANOVA, yung nag-randomize complete block design tayo, no? So, ang goal ng block is actually just to reduce the error, no, na error term. Kasi yung mga unaccounted for na sum of squares na napunta sa error, malilipat siya doon sa blocks natin. Tama, kahit yung blocks natin hindi talaga natin ina-analyze, ang nangyayari is nabawasan yung error natin. Okay? So dahil nabawasan yung error natin, bababa yung MSE value. And kung mababa yung MSE value doon sa Fcalc over, di ba, yung Fcalc natin is MS ng source over MS error. Therefore, mas mataas yung magiging F-calc mo, then more likely na kumbaga sensitive yung ano natin, yung detection whether kung papasok siya sa critical zone or sa non-critical zone. Tama? So similar yung nangyayari dito. If you look at R-squared value, si SSE, the moment na nagdagdag ka ng panibagong variable, always si SSE will go down. Okay? Kasi may na-account kang new, kumbaga if previously unaccounted yung error na yon, dahil nagdagdag ka, kumbaga yung variation, kukunin niya doon sa error. Okay? So always mag-go down to itong SSE. Okay, so regardless of how many variables you place, if you place too many variables, ang mangyayari, mag-overfit yung data mo, and it comes to a point na parang you feel like parang nag-i-improve yung model mo when in fact hindi talaga siya nag-i-improve. So that's why importante na instead of, and iba yung calculation. Let me see, what's the formula for adjusted R squared? Adjusted R squared. Oh. This is the adjusted R squared, no? Ito yung formula, no? Instead of just 1 minus SST over SSC, ang ginagamit niya is 1 minus 1 minus R squared. So it's a complicated formula, no? Multiplied by n minus 1 over n minus capital N minus 1. Okay? So itong adjusted R squared will only increase if yung panibagong independent variable na nilagay mo actually improves the model. And pwede siguro natin tingnan to mamaya, no? So ngayon, di ba, may makita tayong adjusted R squared na ganyan. So when we add the area, kunwari, tingnan natin kung tataas pa siya. If tumaas siya, ibig sabihin yung area na dinagdag natin actually improves the model. No? Alright? So ito, it's quite simple lang yung ginawa natin, tama? Parang isang click lang, nakuha na natin lahat. And that was price and age lang muna. No? So, you look at this, how do we interpret itong value na to, itong data na to? So we can do, itong regression is the model, and ito yung degrees of freedom niya, 1. Tapos residual is siya yung error actually. No? So we can place this as error. So regression, error, tapos yung total, we have 4, no, because we have 5 observations. Ang ginawa kasi natin is age lang muna, no. So kumbaga ilan yung data points na kaya natin mag-plot dito. So we can plot 3645 is one data point, 37 895 is another data point, etc., etc. And therefore meron tayong 5 data points sa ano na to, sa particular system na to. Okay? So, total is 5 minus 1 gives us 4. Tapos, 4 minus 1 is 3. Okay? Tapos, ito SS, sum of squares na, I'll show you later kung paano yung manual calculation ito. No? SS equal siya dito. Tapos, residual error is just ito minus ito. Tapos, you can confuse for MS and MSE. And therefore, after MS and MSE, mag-compute din natin itong F-calc. Itong capital F is the F-calc. Significance F is the p-value actually. Pwede natin p-value. And we can see na the p-value is 0.05, which means that it's lower than 1. No? So, significant yung regression model natin. So, if significant yung regression model, then we can say na in some manner, yung regression model natin or the system is linear, no? Okay? So dito we can have other sets of data set dito, other parang variables. So you can see na meron tayong coefficients. Itong coefficient is kung ano yung magiging final natin na ano, no? So if we were to input the final model, we have y is equal to the coefficient for age is negative 24.38. Let's round up lang natin, no? 39. X, and wala tayong x1 to. Let's just call it x1, no? Kasi later mag-x2 tayo. So x1 plus b natin is 15570.28. Okay, so ito yung magiging predictive model natin. No? Okay? Tapos standard error is just kung gaano ka ano yung plus minus ng ano natin intercept. No, sorry. Ah, tama nga ba? Wait lang class. I think standard error plus minus. I'll have to review no kung anong meaning ng standard error na to. But anyway, ito lang naman ang pinaka-importanting value sa atin. Another important value is itong actually yung p-value dito, no? So, pwede actually makita nyo kung gaano ka-significant yung parang um, yung variable yung coefficient na nandito, no? So for example, ito kung yung coefficient natin na intercept is 0.570 and it's a very low p-value, then we can say na sobrang significant ni intercept, no? Kasi mababa siya yung p-value niya. And age has a p-value of 0.04. It's still lower than 5, then the intercept is ano no is or yung coefficient niya is still significant, no? There are cases wherein yung regression model natin um is kung baga significant yung regression model. So let's call this as the model. Significant yung regression model, pero may cases na kumbaga kahit significant siya, merong mga coefficients na hindi significant, no? So kumbaga mataas yung ano niya, variable. So if you were to choose, for example, kung ano yung tatanggalin nyo sa dataset, so which variable will you remove from the dataset to improve it, then you can use the p-value dito as basis, no? Right? So saglit lang class ha. May kailangan lang akong gawin. Mga 5 minutes. So let's take a short 5-minute break, tapos balik tayo dito. Okay? Okay. Sorry for that class, no? So, balik tayo. So again, nandito na ba lahat? Sorry, Kenneth, Charisse, and Rennie. Nandiyan na ba kayo?
Yes po, sir.
Okay, thank you for the feedback. Sige, hindi na tayo. So where we left off, no? So we did simple linear regression model and we just used the data analysis toolpack for this, no? Pero actually, pwede rin natin gamitin yung pwede tayong kasi some of you may not have no Excel and baka wala kayo nung yung itong data analysis toolpack na to. So we can use a different method, no? And this method also applies for sa anong tawag dito? Sa Google Sheets, no? So if you don't have it, then you can use Google Sheets. See, Google Sheets, this is known as, we'll use line nest na method, no? So we input ito, line nest. So equals line nest is our formula. And si line nest, again, pwede din siyang um, it's a straight line method using the least squares method, and it's the same method na ginagamit dito sa itong regression na sa data analysis toolpack. So both itong Linus at yung regression from data analysis toolpack can be done for simple linear regression pati sa multiple linear regression. So just to illustrate, simple linear regression ulit tayo, and check ko lang na kung may space tayo. Sige, move ko na lang siya konti dyan. Okay. So I'll probably have to label all of this now. Wait. Insert cells down. So sabihin natin na ito is data analysis toolpack method. So ito, let's call this the Linus method. Okay, so sa Linus method is we input equals line nest. Tapos ito, we do known y's, and our known y is this one. And then comma, we input the known x, which is in this case, age lang muna ang gagawin natin, no? Right? Tapos we can input a constant, no? So ito yung same to sa yung pag-check o check and uncheck doon sa, if you remember doon sa linear yung sa regression sa data analysis toolpack natin, may option na i-uncheck natin or check yung constant equals 0. So parang ganito yung second argument na to. So if we set b is set to equal to 0, then when x is 0, y should be 0. So yun yung case na yun. So but if we set it to true, then the b is calculated normally, no? So again, 0 is false, 1 is true. So pwedeng 1 lang ilagay mo, or pwede rin i-type mo true or false, no? It doesn't really matter. So let's just type in 1. Tapos ito, if we want to return additional stats, no? And we want the additional stats because the additional stats is where we will get the different na values, no? So we do yes, we return the additional stats, and we press enter. Okay? Now, dito, just looking at it, no, medyo nag-spit out siya ng a bunch of data, and hindi natin alam kung saan nanggaling yung data na to, no? So if you're confused where the data comes from, pwede actually pindutin nyo lang if you do, if you hover over the line nest na, to, pag kinlik nyo siya, may lalabas na help. Okay? So sa help, dito sa help natin, may makikita tayong, syntax nandito. Tapos naka-display yung anong ibig sabihin ng bawat value, no? So again, si Linus method is a linear regression method na yung formula niya should exist as y equals mx plus b, or if it's multiple linear regression, y equals m1x1, m2x2, m3x3, etc. plus b. Okay? So ito, ano ba yan? Para malaman natin kung anong ibig sabihin ng columns na to, titingnan lang natin itong table na to, no? So M here, this is the slopes. So the first one is MN, which is the slope of the wait. Wait lang klasa. Medyo mataas ba to? What MN minus 1? Kasi yung last yung B eh. Sige. Si MN is the first one, tapos second one, third, fourth, and etc. etc. Ay, dalawa. Anyway, sige. Tapos, yung last mo is, the last variable will be the last column will be for the intercept. Okay? SE here stands for standard error. Tapos, yung R2 is the R squared. SEY is the standard error um, for the response variable. Tapos, F is the F calculated. DF is your degrees of freedom for the model. Tapos, uh, SS reg, itong SS regression, ito yung SS ng model, no? Yung nandito. Tapos, SS resid is the SS residual. Okay? So, dito, in this case, sometimes model, tama. Okay? So, dito, if you look at it, nagmamatch naman sila, no? So, ito yung slope natin. And if you look at here, nandito yung slope. Same sila ng value. So, same lang makukuha natin dito, no? Y is equal to 24.39x1 plus 1570.2. Tapos, ito, 7.01. This is the same standard error as yung nandito sa yung data analysis toolpack method. You can see na 7.01 siya. Tapos dito rin 241. So yung plus minus na same lang din. Tapos yung 0.8 na to, this is your R squared. So if you look at this, this is the R squared. Tapos ito yung R squared value natin, 0.80106. Okay. Then standard error for the Y. So this is the standard error for the regressant or the response variable. It's the same as the standard error dito na. Okay? Tapos yung number of dito, degrees of freedom is the degrees of freedom of the error. So I should probably dito na type ko to. So this is your M1. This is your B. Yung dulo yung B parate. Ito SE, standard error. This is the standard error of your slope. Tapos ito, this is R squared. This is your standard error for the Y. Ito, this is your, this is the F value or F calc. So let's check kung same lang ba. Same, no? Ito yung F calc ito. Then you can compute for p-value by just, if you want to have p-value, let's say, equals F this RT ng value na to. Degrees of freedom 1 is the numerator, which in this case is just 1. No? When you have multiple linear regression, yung model mo is equal to the number, yung degrees of freedom niya is equal to the number of regressors. No? So for example, in this case, simple yung ginawa natin. Therefore, 1 regressor lang. And kung 1 regressor lang tayo, therefore 1 lang degrees of freedom. If you do 2, like for example, isama na natin to si age, si area I mean. If you do area, magiging 2 tong degrees of freedom niya. Okay? So it's 1, tapos yung degrees of freedom ni error is this one right here. Okay? Then you get 0.04018, which is the same p-value dito. Right? Tapos ito, this is just the SS of the regression, or let's call it SS na model. Tapos ito SS error. SS. Okay? So kaya hindi ko ginagamit yung SS yung regression and residual na class, no, na parang notation, kasi mahirap siya i-type. No? Kasi kung wari, tinype ko SSR, parang hindi mo alam kung residual ba to or regression. So, kung gusto mo, pwedeng ssreg, tapos ssres to indicate na yung na-separate sila, no? This means regression and residual. Pero FICO, it's easier if you type it this way, no? Na sum of squares ng model, tapos sum of squares ng error, which is the residual. Okay? So you get this, ano, no? So if you do this, makakabuo ka pa rin ng regression, ng ANOVA table mo, no? So we have SS, DF, MS, FCalc, p-value. Tapos we do model, error, total. So let's try to compute no, kung same ba yung kuha natin. So if you do total, the total the total sum of squares is equal to yung lahat ng nasa response variable natin. Okay? So if we do sum square, so we consider only the response variable no when we do the SS total. So the formula still remains the same no yung kahit yung ito yung same formula na parati nating ginagamit when we do ANOVA table. So it's sum of squares lang lahat ng individual observations. In this case, only for the response variable minus sum yung grand total nito, and we do squared divided by yung total niya no or count. So this is yung correction factor na term kumbaga. Ito. This is the correction factor. Okay, can close this now. No? So you'll see na same tayo ng makuha dito. No? So itong total na to is the same total dito. Okay? Now we can do model is equal to SSM, which is this one. So error is equal to this minus this. Okay? So we have the same values dito now. So MS is equal to bakit i-move ko lang yung table ko. SS pala to. So this is source. Okay, DF is number of regressors, which is 1. Ito, the same formula to, no? Ito. Tapos ito, this is the number of total data points, no? Or you could just say the number of parang data points in the response variable na column. So in this case, it's 4, no? Kasi or equal siya sa 5 minus 1. Or what we can do is count minus 1. Okay? So, MS, compute natin siya. Ito divided by this one. Sorry. Tama. MS. Then we can compute. That's the same value. Same MS. Tapos, we can compute for FCalc, which is, nasaan ba FCalc natin? This one over MS error, which is 12.08, which is also this one. And p-value, same siya sa formula dito. No? Okay? So that's equals F dist RT of this value. And we get p-value. And we can compute for the same, masasolve natin yung same ANOVA table. No? Okay? So wala nga lang siya yung mga additional na to, no? Itong mga standard errors, T-stat, but you can compute for standard error. No? We can, what's the formula for standard error? Ito yung formula for standard error. So standard error for all the slope values is just the MSE divided by yung summation, sum squared ng xi minus x bar, which is ito yung xi minus x bar is yung observed minus yung average. Tapos dito naman SEB is equal to whatever SEM na nakuha nyo multiplied by x summation of xi squared or sum squared na lahat ng observations over n. Okay? So ito I feel like hindi na natin kailangan gawin to, no? Wag na tayo mag-manual calculate ng standard errors. Standard errors are just kumbaga sila yung confidence interval na if you look at it to compute for the confidence interval, you multiply lang natin yung yung slope natin with the t statistic, no? Ito. So if you get this, kaya mo na ma-compute yung plus minus niya. So parang siya yung dito, no, makakompute. Di ba may t-stat tayo dito? If you multiply that by standard error, then that is the plus minus of your intercept. Okay? Tapos age plus minus din ng itong standard error times t-stat. Okay? So again, not that important sa ano natin sa sa case natin, no? Hindi naman natin kailangan malaman yung confidence interval for the slopes and uh, for the uh, for the intercepts. Okay? Meron akong gusto ipakita dito, no? Where is that? This is this might be important, no, itong confidence interval, lalo na sa mga studies, no. Pwede niyo siyang i-explore, no, kasi pwede niyo i-express yung parang predicted na y variable mo, tapos kung ano yung magiging parang plus minus nila. But this value right here is essentially itong standard error na to, no. Itong 244 na nakuha natin. Okay? May gusto ko ipakita sa inyo where you can where is that? Rsquared. Nawawala. Anyway, sige, okay lang. Balik lang tayo dito. Okay? So, actually, R-squared class pa din yung compute din actually manually, no? Kasi if you have the SS error and SS total, pwedeng i-compute siya, no? And let's confirm if same tayo ng R-squared makukuha. R-squared is equal to 1 minus SS error over SST. And you can see na same lang siya, R-squared. Okay? So, you can choose either method, no? You can do itong Linus na method or you can do data analysis toolpack. Linus seems easier, no? Kasi parang isang formula lang siya tas output na. It's just that you need to interpret kung ano yung, or you need to refresh yourselves kung ano yung, kasi hindi niya pinapakita kung ano yung mga values na to, no? So kailangan, if you can't remember it, you just need to look at this one. Tapos tingnan nyo kung anong ibig sabihin ng output niya. So just look at this illustration, no, to show ano ibig sabihin ng ni-return niyang mga values. Okay? Tapos meron pa isa akong papakita method which is the long method, no, the way we usually do it using matrices. And I think okay din ipakita siya para explore nyo kung anong yung mga matrix calculation, no. Pero ito for simple linear regression, hindi natin kailangan gawin yung matrix method, no. Okay, so let's just label this as simple linear regression. And tanggalin na natin yung area. Wait, before natin tanggalin, copy natin siya para sa multiple linear regression naman. Okay, so tanggalin natin si area dito. So, ito yung data natin. And of course, you can also do it individually, yung kunwari price and area. Pwede nyo siya i-compute nyo. So I leave that to you guys as an assignment. No? So try nyo gawin yung simple linear regression model for the area as well. Okay? So try natin mag-multiple linear regression model naman. So this is saying na idadagdag natin si area. So instead of only one variable, ang gagawin natin is we have one independent variable, we'll be having two independent variables or two regressors. Okay? So, yung first method natin, let's do line nest na lang muna, no? So, we do line nest. Tapos known y. This is our known y. Ito. So, dito pala sa line nest method, hindi nyo pwedeng isama yung labels, no? Kasi yung data set lang dapat sinasama nyo. Tapos you do known x. Tapos instead of choosing just one column, ang gagawin natin is we choose two columns, no? Para ganyan. Okay? So again, hindi natin Hindi natin set to 0. So let's set it as true or 1. Tapos let's we want the additional stats, no? So lagay natin siya. Okay? Then we have these values right here. Bakit may n ito? Wait lang, class . Okay. Hindi ko alam kung anong ibig sabihin nun, pero sige. Kasi blanco lang dapat siya. Okay. Tama. Kasi if you look at the Linus method, dito sa dito dapat blanco lang siya. So it makes sense na naka-NA siya dito. Blanco lang kasi to. Okay? So si Linus method, it starts with itong first na column na to. So if you the top two kasi is again puro mga M's to and mga M tapos mga SE. Tama? Tapos dito, yung last column is the let's make it more general. Coefficients dapat lahat ng nasa top na itong nasa top na column row I mean. Yung top row natin puro coefficient siya. Tapos yung second row natin is the standard errors. Okay? Yung first niya is the highest na slope, no? So kunwari kung dalawa to, so siya si M2. Tapos pababa siya, descending order siya. So M2, M1 hanggang we can call it M0, no? M0 is just the slope. Okay? Or the intercept, I mean. Okay? So if we were to add 3, magsisimula tayo with M3, M2, M1, tapos B. Okay? So dito, in this case, itong si 19.3 is the slope for M3. M2. So this becomes Y. Y is equal to, yung model natin will be negative 7.61 X1 plus 19.01 X2. Tama? Kasi ito kasi si M2, di ba? M2, M1. Tapos minus 281.427 or 4243. Okay? Tapos again, hindi natin kailangan yung standard error for now. No? So ito yung model natin. Tapos we can do the ANOVA table. No? And let's see if the ANOVA table is kumbaga if the regression model is significant. No? So we do source, SS, DF, MS, FCalc, p-value. Okay? And we can add conclusion. Source is model, error, total. So total natin, again, sum square ng, again, sa Y lang tayo, no? Sa Y lang pag sa total. Y minus sum, ito, squared divided by count. So again, itong second term na to is just the correction factor, no? Ito. So it makes sense na dapat same lang sila, no? The same data set lang naman to. So error natin is equal to this minus whatever model SS natin. So the SS model is equal to this one. Tama? This is the SS model. Which is, tama no? And actually, may binigay na pala yung SS residual. No? This is SS residual or SS error. So pwede natin actually hindi na total minus model. Pwedeng equals direction ng ganyan. Pero if you want to be sure, para ma-double check nyo, mas maganda na rin na i-compute nyo siya. No? Parang, tapos if same sila, meaning tama yung process na ginawa nyo. Okay? This time, our DF is no longer just, 1. Kasi dito, we have 2 regressors. Tama? So, we have 2. Error natin is just the same formula dito. Tama? So ito, total natin is count to minus 1. So again, I'm just using count class no kasi imagine if sobrang daming ano nito data set. So it would be easier if you just do count instead of hard coding it. Okay? And again, dynamic formulas are always better no than static ones. Pwede natin i-compute yung MS. FCalc is just MS over MSE and 16.8 tapos FDIST naman tayo to get the um, p-value no. So that's FDIST of this value. Degrees of freedom dyan. It is the degrees of freedom numerator, degrees of freedom denominator. And we get 0.05. So in this case, hindi na significant si model, no? Not significant na siya. So the regression model is not significant if you use a 5% na ano no, na 5% level of significance. Okay? Tapos let's do pwede sigurong move ko siya dito to the right. Let's say na Linus to. Now let's do yung ano naman data analysis toolpack na method no. So if we do data analysis, you choose regression again. Tapos yung input Y range natin is this one and sama na natin yung labels no. So click natin labels. Confidence level let's do 95. Constant is not equal to 0 so uncheck. Tapos input range natin X will include the area as well. So ganito lang natin siya pinipili no. Okay? Tapos let's do output range natin. Lagay natin siya. Yeah. That seems good. Tapos pwede siguro hindi natin isama yung residuals no. Yung line fit plots na lang natin. By the way, yung residuals if you can see dito, ito kasi yung residual output niya no. You can see na ano siya. The residuals kasi is again equal to sa y observed minus y expected no. Ganyan. So if you add the expected so kung ito yung residuals, forgot the term for residuals, parang epsilon nata. So let's just say E ang residuals no. May specific value to. Was it epsilon? So let's just do E no or sige type ko na lang res. Residuals is equal to the observed minus the expected. So if you add the residuals to the expected or the predicted, then you can have the observed value. So kung i-add mo to 745, you can see na ito siya 745. So if we bring that down, same values ito. 895, 442, 440, 1598. So yun yung ibig sabihin ng residuals. So, meron itong mga notation eh. I think y observed is this is yi no. Yi usually yung ano na notation. Yung predicted is y hat no. Y hat. Yung y hat, what does y hat? Let me familiar kayo sa hat na symbol. So yung kunwari y hat. So I'm not sure ano pang I think ES also uses the hat symbol no. At si math din gumagamit ng hat symbol. So y hat here means that it is the predicted value or the expected value no. Okay? So check mo nga. Meron bang y hat dito? Y hat. Hindi nagamit ba y hat? yi. Y bar. Although hindi naman siya nagmamatter no pero I know it's y hat eh. Sige, hindi natin makikita. Anyway, hindi na masyado importante yun no. So buray na lang natin to. Okay? So dito tayo. So we can check the adjusted R squared class no. So we can see na Yung R squared dito is 0.94391. Tapos again, if you look at it, nag-increase talaga siya, no? Pero hindi natin sure kung yung increase ba na yon is a result of overfitting or ang totoo ba niya is nag-increase talaga siya dahil the area variable has a kumbaga it improved the model. Okay, so the way we check that is we check the adjusted R square. So ang adjusted R square niya was 0.734. Then when we added the adjusted R squared, naging 0.88781. Okay, so nag-improve yung model. Okay, so siguro maybe some of you are asking, no, and I myself I'm asking, no, because it's a little bit weird because the adjusted R squared increased. So ibig sabihin nito na-improve yung model niya, pero yung model actually natin naging non-significant. Significant siya dito, it's 0.04, pero non-significant siya. So I'll have to check kung ano yung implication nun class, no, kasi I'll bit na medyo na-stump din ako dito. So maybe I'll just forward it to you guys, no, kung anong ibig sabihin nito. But in any case, we can tell na by adding the area na variable, the model has been significantly improved, no? Okay? So this is for your for some of your studies, no, lalo na yung mga kukuha ng data set from, like for example, kukuha ng data set from different agencies na publicly available through the internet. You can also do this method, no? Parang gagawin nyo is check nyo kung alin yung variables na mag-improve sa model nyo. So you can add variables, remove variables, tapos tingnan nyo yung resulting R adjusted na. Itong adjusted R squared. If it increased, then ibig sabihin nag-improve siya ng model. If it decreased, then it does not improve the model. Okay? So ito. Nandito din pala siya. So, predicted residuals. Ito yung residual output natin. And ito yung plots, no? So, we have two plots for the area. Tapos may plot din tayo for the age, no? Okay? Tapos we can see that nandito yung mga ano natin, no? Intercepts natin. So, we have the same intercept dito. Sorry, we have the same coefficients, I mean. So intercept natin is negative 281.427, negative 7 sa age. The area naman is 19.0103. Okay? Tapos if you want, you can compute for the yung confidence interval by using the standard errors and the t statistic or t values. Hindi natin gagawin yon. P values. You can look at the p values, no? The p-values are actually really high, no? Parang ito p-value ng intercept. Itong age din, p-value niya mataas. Tapos si area p-value is also high, no? So that's why naging probably contributed to the non-significance ng regression nito. Okay? So, I think this makes sense, no? If you parang just think about it, no? Kasi the more variables you place, and lalo na pagka siya, yung mga variables natin, yung ibang variables does not have a super linear relationship, no? Mangyayari is the more you input doon sa multiple linear regression model natin, then the more likely na hindi siya magiging hindi siya magiging significant. So or kumbaga mas tataas yung chance na hindi magiging significant yung model natin because you added multiple variables, no? Okay? So probably if we did, I think if we just did area, no? Kasi area seems to be more parang mas nag-fit yung maybe we can do it mabilisan lang, no? Let's just do mabilis lang. And we do the Linus method na lang para mas mabilis. So if we do equals Linus nito and the area is constant not equal to, let's compute it normally. Additional stats, yes. Tapos, let's do ANOVA para dito. No? Source, SS, TF, MS, FCalc, and p-value. Let's compare. And again, this is I'm doing it individually. No? So this one is, this data set is for your age versus area. Ito, age versus price. This is area versus price. Okay, so let's do model, error, total, and that's ano siya. So sum square, actually, hindi ko na i-compute, no? Pwede namang, let's show, kunin ko na yung error. This is for the model. Tapos DF, we have 1 kasi 1 regressor lang. Tapos error natin is 3, no? Kasi 4 minus 1. Tama? So, ito, definitely class, pag kayo gumawa nito, dapat i-fill out nyo lahat ng tables. Pero ito, skip ko lang kasi may i-check lang tayo. No? DF, MS. So we have FCalc, this one over this one. And we can see, already I can see na FCalc is very large. No? So, mas, kumbaga, further right pa siya dito sa 12, sa FCalc na to. No? So we can have p-value is equal to 0.0, sorry, F dist RT, degrees of freedom 1, degrees of freedom 2. So it's a very small value. So mas kumbaga significant talaga ang model if you just do area, no. So, and this goes the same way, no. Parang mas maganda kung ma-compute natin yung adjusted R square, no. Let's compute for the adjusted R square. Let's compute for it manually, no. R square. The adjusted R square is given by this formula. So that's 1 minus R squared over N minus 1. N minus capital N minus 1. Ano nga ulit yung capital N dito? I think capital N is the number of regressors while N is the total observations. Okay? So try natin compute, no? R squared. So if we compute for the adjusted R squared dito, so let's call it R squared A. Adjusted R squared is equal to, that's 1 minus quantity, we do 1 minus R squared. So that's 1 minus, what's our R squared? Itong 0.92, no? This one. 0.92 times N minus 1. N minus 1 natin is, total is, 4. That's 5 minus 1. That was divided by N minus capital N minus 1. So, N is 5 minus small n is 1 minus 1. Tama? Nasusundan ba, class? Okay pa naman, no? Sorry if I'm going a little bit fast. Sabihin niyo lang kung masyado mabilis yun, ano ko. Pero ito yung manual calculation natin for adjusted R squared. Okay? So if we, may typo ba ako? What's my typo? So tama, may times pala dapat. Okay? So ito, times ito. So this is our adjusted R squared. Okay? So ito yung adjusted R squared natin. So, take a look at the difference, class, no? That kanina, let's compute the R squared for, compute natin ng R squared dito. Let's just place it here lang siguro. R squared adjusted. R squared adjusted nito. So it's 0.73476, which is the same value as this one right here. No? Okay? So ito yung first adjusted R squared natin. Tama? Nung age yung ginamit natin, adjusted R squared natin is 0.73, and we noted na nung dinagdag si area, nag-improve yung model, no? Kasi naging 0.88 siya. Tama? Or 0.89. Now take a look at what happens when from dito, it's 0.89 yung adjusted R squared ni area. Kasi di ba single lang ginawa natin dito. Adjusted R squared, ito yung adjusted R squared niya. Okay? 0.89. 89674. Tama? Nung area lang versus price. Now, nung nag-multiple tayo, that's saying na dinagdag natin si age. ang nangyari is naging 0.88 siya. Tama? 0.887. So, ibig sabihin, yung variable na dinagdag natin, which is, in this case, no, if you look at it from this perspective, nagdagdag tayo ng um, nagdagdag tayo ng age. Ang nangyari is, ang model actually decreased, no? Parang, or did not improve. So, ibig sabihin, in this particular case, si age does not help improve the model. Okay? So, yun. Yun siguro yung mga, class ng mga intricacies dito sa multiple linear regression model, how we sort of look at things in perspective, no? Kumbaga, nagbabago siya kasi pwede kang magsimula with 1 tapos kunwari ito, nagsimula tayo with just age, no? Tapos nung dinagdag sa area, nag-improve naman siya. Pero we can also look at it in the opposite way, no? Nang simula tayo sa area, dinagdag natin ng age, tapos uh, hindi nag-improve yung model. In fact, nag-worsen siya kasi bumaba yung adjusted R-squared. Tapos ito yung sinasabi natin kanina na overfitting, no? If you look at it, 92 yung R-squared dito, pero dito it's 94. Tama? So parang if you just relied on R-squared itself, you will have a false sense of improvement, no? Kasi parang biruin mo from 0.92 dito, nung dinagdag mo si age, naging 0.94 siya. So if you did not know about adjusted R-square, pwede mong masabi na nag-improve yung model. No, but no, it's not improved, no. Nag-ano lang siya, nag-overfit lang siya kumbaga. So again, for multiple linear regression, if you want to know if the model has improved or not, adjusted yung i-check, no. Okay? So, dito class, no, I've shown you two methods. Itong kompletuhin ko na nga to para, actually, same lang pala to. So, I've shown you two methods, no, itong Linus Method saka data analysis toolpack. And kayo mag-decide kung ano yung mas madali. Definitely, mas maganda itsura nitong no, itong si data analysis toolpack kasi mas mabilis siya. Tapos, naka-layout na lahat. Pero ako, I like the Linus method, no, kasi nag-work siya kahit hindi Excel. So, for example, kahit spread, ang gamitin natin is Google Sheets, pwede tayong mag-Linus method. There is another method, and this is the long method, no? That I feel like I should also, no? Data analysis. That I should also introduce to you guys, no? Kasi baka magamit nyo din yung formula na ma-introduce dito. So, this is called the matrix method, no? Or parang manual method, pero let's call it the matrix method. So, ito definitely feel ko walang gagamit ito kasi masyado siya matrabaho, no? Pero baka lang magustuhan niyo siya tapos ma-apply niyo din yung matrix calculation in your other fields, no? Or other subjects. So let's take the matrix method. So matrix method is when we do calculations, no? Or when we solve for the models, actually tinitingnan lang actually natin is parang manipulation lang siya in terms of the matrix form of the data set, no? Parang ganun. So if you look at it, ito kasi yung matrix form niya ng data set. Nakaganyan siya. So this is the Y matrix is equal to the M matrix, the X values multiplied by the coefficients. So it's B1, M1, M2. Ganyan. So when we do itong matrix calculations na to and we simplify, what we end up having is, hindi pinakita dito, no? Okay, hindi niya pakita. Let me look for it. Wait lang, class. Let me look into my files. So, kahit dito sa no, hindi na pinakita pero I think it's worthwhile showing. No? Let's do linear regression. Ito. So, if you did the math, ganito yung itsura niya, class. No? Okay? So, ganito yung matrix calculation. No? So, we need to form this matrix. No? So, let's just call this as ito yung matrix A. Call this as matrix B. And let's call this as matrix Y. Para ganyan. Also, gawin ko na lang X. Let's call this X matrix, the B matrix, and the Y matrix. Okay? So what we do is we first form the data of the matrices. So wait, draw. Okay. So the first one is just the n value, no? So n value, that's the n value is yung count, no? The count of the data set. In this case, we have equal to 8 dapat siya because there are 8 variables dito, no? Tama? So we do equals count. Ito. Tama nga ba? 8. Let me double check last, no? Kung 8. N is, oh no, sorry. N is equal to 5. Tama. Sorry. N should be equal to 5. Kasi similar pala dun sa dito sa degrees of freedom. Ang kinakount lang natin is yung y value, no? So this should be 5. Tapos next is, I feel like wait lang. Ilipat ko to dito, no, para mas it's closer to siya sa natin. Okay? Ito pa natin dito. So, this is the first one is, let's call this the X matrix, no? Tapos dito, so it's a 3 by 3. Next is B, and let's do si Y na dito. Okay? So, ito 5, this is just the number of response variable observations. Tapos X1I, summation of X1I is just the sum ng lahat ng X1 terms. Tama? Parang ganyan. So this is X1, this is X2. Okay? Now dito, this is sum of X2 terms. So that's sum all X2 terms. Okay? Here is the sum of X1 terms. So this is a symmetrical matrix, no? Symmetrical around the diagonal. So that's 153. Tapos this is equal to X2I dito. So this is the same. 352. Tapos dito, this is sum of the squared values of X1. So this is actually just sum square, no? Sum square nito. Tapos dito, this is the sum of X2 squared naman. So this becomes sum square ng X2. Okay? Oops. Okay? Tapos we have this is the sum of X1 times X2. So I think we have a formula for that, and this is the sum product, no? So sum product is you multiply it first before adding it. Okay? So we do sum product, and the first array is this one, X1, multiplied by the second array, which is this one. So again, kaya gusto ko ituro to class, no? Because it involves some other formulas that might be useful if you're doing other calculations, no? For example, sum product. First time ko ata in-introduce ng sum product, no? Anyway, we have sum product. Tapos this is also the same, no? Sum product lang dito. So we can just copy this. Because again, symmetrical sila. So that's our first matrix, no? Now our second matrix is actually a result, no? So this is our B naught. B naught is, yung beta naught is just actually the B. Tapos si beta 1 is M1, the slope. Tapos beta 2 is just M2. Okay, so let's call it that, no? Tapos yung y natin is equal to, yung first column is just summation of y equals summation of y. Second value sa matrix na to is summation of x1 times yi. So that's sum product again of x and y. So hindi nagmamatter na kung alin yung unang array na yung ano ko kasi multiply lang din naman. So we can do it like that. Tapos sum product last natin is x2 naman times yi. Okay, so we have x2 times y. Okay? So ito na yung mga matrices natin. Now, if you remember your linear algebra, no? If you have a matrix that looks like this, x, if you have y is equal to x times b, then kasi ang hinahanap natin is b, no? Ito. So then b is just equal to y if we transpose y multiplied by x. Tama? Or x multiplied by y transpose. So, naalala nyo pa ba to? Sa linear algebra? Yan, medyo tama naman nata to. Okay? So, ang gagawin natin is we use a formula, no? Ang formula na gagamitin natin is M-mult. Okay? So, if we do M-mult, this is matrix multiplication. So we do M-mult ng array na to multiplied by wait lang. Kailan ko ba i-transform pa to? Let me double check. Bakit pwede siya? Let me double check last time. Dapat i-inverse ko muna to. So let's do y inverse, no? Or is it y inverse? Oh, inverse pala. Sorry, not transpose class. Transpose is when you, kumbaga, yung transpose is when you ibabalik-tarin mo yung rows and columns, no? So, we're not looking for transpose, we're looking for inverse. Yung ganito yung symbol niya eh. Yung ganito. Kunwari, matrix A, yung inverse niya is matrix A to the negative 1. Transpose is yung A, T. Tama? So, A to the negative 1 yung ano natin. Pero since walang A to the negative 1 dito, ang gagamitin ko na lang is just apostrophe A prime. Pero what I mean there is A to the negative 1 or inverse. So we need to get the inverse of this matrix first, no? So we go inverse M inverse, sorry. Yung pala yung formula. M inverse. So we get the inverse of this matrix right here. And to get the M inverse, kailangan pala natin siyang i-present as an array, no? So we need to do this. Kasi it's an array function, gagawin natin is equals M inverse. Tapos, isa-select natin yung 3. Tapos we do M inverse. Okay, so again, ang first step is, ito yung medyo sa matrix calculations, no? Kasi there are, we are using array formulas dito when we do matrix calculation. So, again, una, select mo muna to. Then you do M inverse. Tapos select mo to. Then before you press enter, i-hold nyo yung control and shift. So you do control shift enter. Wait, bakit ayaw lumabas ng M inverse? Wait lang class kasi ito naka-matrix naman siya. M inverse. Let's see kung ano yung error. Help on this error. Check natin, no? Let me double check my notes class now. Wait lang. Okay. Okay. Alam ko naman pala bakit. Um, the problem is mali yung ginawa natin, no? Sorry. Ah, kasi hindi ka pwede mag-inverse ng hindi square matrix, no? Meaning yung matrix mo is same yung number of rows and columns. So ang i-inverse natin is actually yung x prime pala, sorry. It's not y prime. So it's actually if y is equal to x times b, then to get b, it's actually the inverse of x times y. Ganyan. So hindi siya hindi pwedeng pagbalik rin, no? Dapat si x yung i-inverse mo as opposed to y. So I forgot the property, no, na probably I'm looking kasi x times b dapat pag si x yung tina-transfer, di ba? Tama because tama kasi si x yung tina-transpose natin doon sa kabilang side, therefore si x dapat yung ini-inverse. Okay, na I now remember now. So dapat x inverse nitong matrix na to. Okay, so dapat mag-work na to, no? So again, we select the data set, tapos we do m inverse, tapos itong array na to of the square matrix. And before you press enter, gagawin natin is we press control and shift, no? So if you press control shift, mangyayari is if you fill out niya to. So you know that it's tama yung ginawa nyo if mag-fill out siya ng ganito. Pero I think it's necessary sa older Excel versions, no, yung control shift. You'll know that it's an array function kung if you look at the formula, no, meron siyang curly brackets. If naka-curly brackets siya, ibig sabihin naka-array formula siya. Pero let me try na hindi ko kasi ang alam ko yung new Excel, yung mga newer versions of Excel, no, if you have Office 365, hindi na necessary i-M inverse mo, i-array formula mo to, no? Pero let's double check. If I do M inverse, ayan, okay. Automatic na pala siya, class, no? So in older versions of Excel, and I'm not sure if Google Sheets actually require you to do array formulas as well. Pero in older versions, kailangan gawin nyo yung control shift enter. Pero dito, mukhang hindi na, no? Automatic siya na if you look at this blue border na to, siya na nag-identify na it's an array formula and siya yung mag-autofill ng Okay, so okay na tayo. So x we have x inverse. Therefore, kaya na natin ma-solve itong b na to, no? So if we do mmult ng x inverse natin, which is this array, multiply it by the y array right here, then we get itong values na to. And this values is equal to yung b, m1, and m2. Okay? So ito yung mga coefficients natin. Okay? So that's the long method, no? And let me lipat ko na lang dito siya. So, lipat natin siya dyan para ma-compare natin yung results, no? Okay. So you can see na same naman yung na-calculate natin, no? Wherein meron tayong same coefficients. You get negative 281.43 for the B, negative 7.611 for the A coefficient, tapos you get 19.01 para sa slope number 2 or sa x1 na slope. Okay? Then from here, pwede na tayo mag-compute, no, ng sige, kompletuhin natin to. And by the way, this is how we used to do it, no, nung wala pang Excel. Not necessarily matrix calculations, pero kumbaga ang ginagawa namin noon is ganito yung ginagawa dati, no, nung wala pang Excel. So i-compute namin to. Tapos after computing, if you do the matrix calculation, no, pag distribute mo to, you'll actually have 3 equations and 3 unknowns. So mangyayari is you'll end up with something that looks like this. Tapos ito yung kina-calculate namin. So 3 equations, 3 unknowns, and then we can solve for yung B0, B1, and B2. Okay? So ngayon, dahil nga sa ano natin, with the advent of technology, no, pwede na tayong kumbaga mabilisan na lang yung calculations, no. So you can do this matrix method right here, or pwede naman Linus or data analysis two-pack. And siguro since may time pa naman tayo, no, we can probably finish this up, no. Source natin SS, DF, MS, FCALC, PVAL. So ito, total is SST, total natin is sum squared. Actually, same value, same formula to. So let me just copy this. Same value yan. Tapos ito, equal siya sa this value minus this value. Ito, kailangan manual natin compute yung SS model, no? And the manual calculation for SS model is shown here. Where's the formula? Sorry. SS regression. Sorry. We compute for the SS error tapos tsaka natin makukuha yung SS model. So to compute for the SS error, we use this formula, no? Ito. So let's copy that. So SS error is equal to summation of the yi squared. So that's sum squared nito column minus yung B naught or beta naught, which is our this value right here, so yung intercept. Tapos multiplied by, so it's a long formula, no? Multiplied by yung yi, which is sum ng yi nito. Okay? Minus beta 1, which is this value, times sum ng xi times yi. So that's sum product yung gagamitin natin, no? Sum product ng xi, x1 times yi. And then, tapos, you can imagine, no, na pwede mo pang i-extend to kasi this is for simple linear regression lang, no? Since dalawa tayo, magdadagdag pa tayo ng yung B term, no? So if it's B term, you can follow the pattern. Sum product ng x2 naman and yi. Okay? Compute that. You should get sorry. Bakit nag-add ako? Minus to. Supposed to be minus. Tama ba? Minus. And you get, if you did it correctly, no? Let's compare 50693.01. This is also 50693.1. Okay? So that's how we used to calculate it, class, no? This one total plus error minus, sorry. Total minus error now becomes the SS model. Okay? So DF nito, this is 2. This is 3. Sorry, this is 2. This is 4. Nama? This is 5 minus 1. Minus 1. And again, MS error natin is DSS over DF. FCalc is MS over error. Pval is FDIS RT. FCalc. Numerator, then denominator. Okay? And you get the same values dito, no? So obviously, I don't think any of you will use the matrix method, no? Kasi it's much more difficult. You need to remember more formulas. So I don't suggest using the matrix method, no? Pero the techniques you learned here, baka pwede nyo magamit sa other calculations. Or from the class pa, meron bang gustong gumamit nitong matrix method? Kenneth, Charisse, and Rani?
Wala po.
Sige.
Wala po.
Sige. So, kalimutan nyo na lang itong matrix method. Although, yung importante dito, class, no, yung new formula na tinuro ko, I think magagamit ito. Some product is useful, no? Also, itong matrix calculation is also useful. So, you can use that. From what you've learned today, before we end the session, no, tingin nyo anong yung most likely na gagamitin nyo? Would you use the Linus method or data analysis tool?
Ako po data analysis po sa akin.
Okay, kasi
Pero parang maganda rin po yung Linus.
So, yun. Yung data analysis tool pa kasi naka-table siya, no? Medyo maganda. Pero kung gusto mo mas minimal, kasi minsan medyo cluttered to, no? Sometimes gusto mo minimal lang yung results. I suggest Linus method. No? How about the others? Kenneth tsaka Renee, meron ba kayong preference?
Pang same po kay Charis po sa data analysis na lang siguro. Kahit medyo cluttered. Parang mas assured ako dun sa...
Sa bagay.
Pag may Excel po na parang gamit, yung data analysis na lang po. Pero pag Google Sheets lang po meron, sa Linus na lang po ang gagamitin.
Mas okay din kasi sa Excel kasi may Office Live naman po na
sa bagay. Pwede pala kayong mag-share na sa no, if you're logged into an account, pwede nang mag-share kayo ng documents and you can work similar to Sheets, no. So yeah, pwede naman lalo na pagka since lahat naman ng UP students may free Office 365, no. So why not take advantage of the available tools, no. Okay? So yun lang siguro. So thank you for coming in today, no, Kenneth, Charis, and Renee. And that is multiple linear regression method, and later tayo, no? Next meeting mag RSM naman tayo, which is the hardest, I think, si RSM. Come to think of it, no? Kung wala tong matrix method pala, sobrang dali, parang madali lang pala yung linear regression, no? Tama?
Opo.
Parang relatively it's easier, no? Okay. So, scratch yung sinabi ko last week na sabi ko isa to sa hardest, no? Isa pala to sa easiest if hindi matrix method gagamitin. Okay? So, I think we can end the recording and si Kenneth, may question ka na. So, end ko na yung recording. Tapos, if you have